Today we're going to talk about points of view. Now, what do I mean by points of view? So what we're going to do is break this audience up into three groups. Everybody over here is going to be the USGS, okay? Everybody over here is going to be local governments, all right? And then the third group, the Ptarmigan Ridge Elementary School PTA, that's everybody on Zoom. So Carol, you're going to have to interact with the folks on Zoom. And I'm going to, at the end of the talk, we're going to weigh in on your points of view on this. And you're going to find out that this seemingly innocent topic is rife with a lot of gnashing of teeth, I guess is the best way to put it. But yeah, we'll go through what the volcano and what it's doing out there. And it looks pretty straightforward in terms of that. Pat Pringle tells me we say that Osceola mud flow. And then we'll have this discussion between the USGS, the government, local government, and then the PTA. The USGS, as you guys know, is basically in charge. This is their charge with the US Congress, has told them to do all these things. And you certainly know Clarence King was one of the first presidents, and John Wesley Powell, who really had a lot to say about the climatic impacts of where the West was dry. They said that you plow the soil and the water will come, and he just said that was just so much malarkey, and he was right. And so USGS gets its hands involved in a lot of things. All right, so this is actually one thing that is interesting in terms of how the USGS views their charge and whether they're supposed to look at prediction and versus forecast. And Pat said this is a big issue in terms of you have to think, if you're a USGS person, you have to think about but predictions is something that's actually happening. And so you have something you can measure, and you'll see the result of that later on in this talk versus a forecast, which is kind of like we have some evidence that we're overdue for a Cascade subduction zone quake. And so that's more of a forecast. We also, part of the charge of the USGS is what we have. We're blessed with having the Cascade Volcano Observatory right nearby. And these are the peaks that they're monitoring nearby. And that's, I put their mission statement up there just so you kind of understand what the role of the national government is in this region. And it's, you wouldn't certainly have a CVO in Omaha, Nebraska, but we have the volcanoes, and so we have one. This is switching over to the local government. We have this kind of infrastructure here in Portland. It's called Portland Bureau of Emergency Management. But this is in Pierce County, where most of this population center that's near in the shadow of Mount Rainier is located in Pierce County. And so these folks over here, this is going to be your job assignment. So when you get up in the morning, you'll go to Tacoma and report in. The town that we're going to pick on is Orting, and it's often in the news for reasons I'm going to explain. But it is actually, your local government is also represented here. So not only are you going to be Pierce County, there's an outfit called EPIC up there that's trying to raise awareness, and then you're going to have the local government there in Orting. This is Pierce County, and you see there's really not many folks in the national park, and certainly in the slopes around there, and that's a good thing. I don't know, Scott, if you know why there isn't anybody up there, but it's all forest, and it's I don't know if there's a prohibition of building in there or what, but it's not a good place to live if you're going to be near a big volcano.
Show us where Orting is on that map.
Yeah, the big red star. Yeah. So the population is about 1 million people in this area, and Orting's only 9,000 folks, and so But this is the PTA. You folks on Zoom, you're going to be a part of the PTA for Ptarmigan Ridge. Your kids go to school here, and so we want to hear if you think your kids are safe after this presentation. So I'm going to give you a contextual view, a Zoom view or a Google Earth view of the valley. You've got Ptarmigan Ridge in the star here, and then I also put in another kind of a mass casualty that's not the right word, potential in this state of Washington soldier home, which is down here by the star. So they're down in the valley. You'll see that there's definitely some effort to do something about it. But again, we'll get to that across that bridge when we come to it. But that's where these are located. And just to give you a sense of what these are, you've got the town in the valley, and you got these slopes that are quite high. They're very friable. They're actually the former Osceola land mud flow that flowed through here. And so they're friable. They decompose. They're not rigid by any means. So they slough off. And then you also have the Puyallup River on this side, and then the Carbon River, which brought the Osceola mud flow into this area 5,600 years ago. So that's what we're dealing with. And so we'll back away from this for right now. We'll talk a little bit about stuff that most of you guys know about. And this is a volcano. It's basically a stratovolcano that we have along the axis of the Cascades. And there's lots going on here. And, you know, and we see a lot of this activity pretty much on these kind of volcanoes all the time. Now, if you'd go over to Kilauea, you wouldn't see hardly any of this activity. You'd see some of it. You'd see basically a fountaining at the vent, and then and certainly the lava flows. But the rest of that stuff is really relegated to the big straight composite cone, as we call them. And this is basically in the world. We have quite a few volcanoes out there. Basically part of the subduction system, and in the U.S. we've got 161, of which the very high risk ones are about 18, and they're mostly up in Alaska where there's not too much worry. But the USGS watches this, and you can sign up for alerts on the web to get any of these. There's Alaska Volcano Observatory, there's Hawaiian Volcano Observatory, and they can give you the information on all these. And mostly what they're watching for is when the plume of ash gets up into the stratosphere, whether they have to divert a flight. So they're watching that very close. And certainly if you were to have one of these cascade volcanoes, you'd certainly influence the airline traffic up and down the west coast here. So this is basically what we have in terms of the instrumentation going on. And you'll see that 1980, that was when Mount St. Helens, I mean, they got started there. But the thing that really kicked this off was the 1985 Nevada Del Ruiz eruption down in Colombia. And we'll talk about that at length a little bit. But once that happened, and you'll see that was, well, we'll talk about that when we get there, but following 1985, that kicked up, and then you'll see that we are starting to really instrument things left and right out there right now. So this is the mountain. It's incredible. It's huge. You know, it's sticks way up there too. And that's a factor that we'll discuss. I mean, it's high enough to where it intercepts all the storm systems coming through. And it's basically prior to 1500, and when the Osceola mud flow occurred, it used to be up to 16,000 feet. So, and you'll see here in a second where that was. It's about 500,000 years old. Still supports 25 glaciers because it has a lot of elevation. It does continue to get precipitation. It's one of the one of the mountains that supports glaciers that tend not to be diminishing. They are, some of them are getting smaller, but they seem to be holding their own. And then the key thing down here in the Holocene, they've had 55 of these Lahars for reasons we'll talk about. And then if you do the math on that, that comes out to every 200 years, you're likely to get one. Again, that's just dividing these numbers out. That's not a firm, reliable clustering of data. But in volcanoes come around, especially on where you have a subduction zone where the plate, the oceanic plate is starting to melt, and then the lighter material here floats up to the top, bringing its heats with it, and then produces the volcano as we go. And in this mess, I just wanted to point out where Rainier is, but it's right at the border where Silesia and then the North Cascades terrain really meet up in that neck of the woods. This is kind of when it started, about 500,000 years ago, and first 100,000 years it produced a lot, and then it kind of slacked off for 100,000, and then it really produced a lot, and then right now it's in a kind of a slack period. And these certainly correspond to different spurts in subduction activity as the plates go. That's Mount Rainier, and I'll go through how the USGS looks at all the volcanoes in the country, and these are the ones they consider most dangerous. Kilauea, we'll talk about the first three anyway, Mount St. Helens and Rainier. And Kilauea is considered dangerous because if you live downstream from it, you certainly know that it's not a good place to live if you got a volcano in your neck of the woods. So these flows continue. They lost 1,800 homes a couple of years ago. I think that was 2018, Scott, and downstream from this flow. And it's dangerous because of the lava flows. You know, the railroad or the volcano is a little bit benign itself. It does inflate, and then the lava flow comes down the hill, building onto the island of Hawaii. And Mauna Loa, as you know, over Christmas was there, and I had a friend ask me if should she go, and I says, well, you're fine as long as the lava flow stays on the east side, and if it's on the west side, you won't have much time. And they probably would have evacuated Kona, but it tended to go to the east. Mount St. Helens, you know all about that, about the lateral blast, and it definitely is a candidate for rebuilding itself and continuing to be explosive in the future. There's really nothing that suggests that trend's going to change. And then you've got Mount Rainier, and it's dangerous for one we just mentioned, the Lahar potential, and why it produces so much Lahars. And then you get also pyroclastic flows should it have an eruption. And the situation where you have a pyroclastic flow and the hot material lands on the glaciers is probably the worst possible condition. So you're going to see that down in Colombia. It's also considered a decade volcano, which is not a good thing to be on this list, because it's really they went around the world in terms of volcanoes that you don't want to live next to. So Rainier is on that list, and the other ones I've given, other talks about Colima, Santa Maria, all these right in through this area. These are not good neighbors. Okay, and then if you on the guides, you see that the ones down in Merapi and in Indonesia has been going off quite a bit lately too, and as well as Tal in the Philippines. And then so this is why you're right in the shadow of Mount Rainier. It's a majestic mountain, and you can't help but notice it when you're there. But it is right there. It's not like it's too far away. And these lahars that it produces are basically there's 5 or 6 mechanisms that can produce them, and basically you get this if you get any kind of eruption, minor, major or minor, it's going to trigger these lahars, just because of the snow and the glaciers up on top. If you get heavy rainfall and a rain on snow event, which we had in '96 here, was definitely could trigger something like that. There's not much of a crater lake up on top, but if you folks are following the one in India, they just had one on October the 3rd, I think it was. It was a one that they were watching. It was one they had instrumented, and you know, they just fell asleep on the day that they needed to take action. And then you do get the one worry that they had at Mount St. Helens, they put up the sedimentation structure, is you get a minor flow dams it up, and that's kind of what happened in India. And then you get it overtops it. In this case, it was a terminal moraine that got overtopped. You can also get the magma moving up into the chamber, and it will oversteepen some of the hills. And then you get this other one that's the rock weakened by acidic acid. We'll talk about that. And then what happened in the Osceola, they had a minor mud flow the year 100 years before, and it kind of undercut the Osceola one, and then it destabilized that to the point where 100 years later it flowed. And then you've got three types of lahars based on composition of the material, and this is the way they look at it: class 1 or case 1, case 2, and case 3. And you'll see that the clay-rich lahars are the ones that are very slippery and they flow very fast, and those are the ones that have the danger. And that was the Osceola one. This is in Pakistan, and it's you see this is the beginning of a major lahar coming through this community, and you'll see it's but these lahars are, as you notice, that they're obviously they're off Rainier, but they, oh, there it goes. We don't have any noise, do we? Yeah, this tends to be in the front of the lahar. You'll see in a minute that the looser stuff comes. All right, so the what's happening is lahar comes down the valley. It's picking up all those rocks and shoving them ahead of it. And so the front of a lahar is going to be pretty daunting, like a battering ram. And you'll see it's quite high when the front goes by, and then you see it. This stuff is what we call we just call that goose shit, but it spreads everywhere. Okay, it's not cohesive. It's got a lot of clay in it, and that sort of thing. But we'll go to the next one here. But you can see it's angular rocks that are carried by a matrix of clay, and they'll support them. Those rocks are floating. Okay, rocks don't float, but they're floating, and they'll carry it along. And there's definitely some differences between this and a glacial outwash. Okay, it has a lot to do with this, and this is also very, very hot. You know, this will char wood. But this is also a lahar that just happened just up in, and this is one of the Cascade volcanoes that's up in British Columbia, and this happened just a few years ago, a major lahar that came down Mount Mahar. So what happened here was, you know, we really didn't understand that this was a mud flow until Rocky Crandall here in 71 published his paper. He had some thoughts about it in 56. The previous geologist that did the work in here was Bailey Willis. back at the turn of the century, and he identified all that area in the where he says the mud flow. He called that glacial outwash plain. And then when Rocky was looking at it, he said, "Well, this doesn't look like it. This looks like something else." And he didn't really know what it was. And all the evidence that he kept seeing, it kept pointing to Mount Rainier, but the scale of that was what blew him away. He just couldn't put those two together, and then he finally published this paper. It's quite a good paper, this 1971 paper of Crandall. And he was one of the two with Molyneux that predicted Mount St. Helens going off. In 1978, he published the report on the Cascade volcanoes and predicted Mount St. Helens was going to go off before the turn of the century, which it happened 2 years later. But this is basically the Osceola mud flow over here by Buckley, and it hit at Human Claw area, and then it flowed. It stays right in these river canyons here, river valleys, and went all the way up to Duwamish and filled in a good portion of Commencement Bay there at Tacoma. And there's evidence underwater there for that one that happened 5,600 years ago. And then down the Nisqually River, you've had a couple flow down here as well. And then the Electron one is the most recent one. That was in 1501. So that's fairly recent. And that one was triggered just by the sloughing off of a portion of the sunset area of Mount Rainier. There was absolutely no eruption, no rainfall, nothing that triggered it other than it got weak and fell down. These are the speeds that these things go. You multiply this by 2 miles an hour. So you can see these, I think this is the Japanese, this is worldwide numbers, but just to give you a number of how fast these things go, if you use 40 kilometers an hour, roughly about 25 miles an hour, that's typical on the speed of Lahar. So that's kind of one of the things that it's hard to understand. That you saw that video where they basically, that was probably doing 25 to 30 miles an hour. So they're quite fast. This is looking down at the top at the Osceola mudflow that triggered, and it was again that it had a precursor mudflow 100 years prior, and then they had a slight eruption that triggered this, and it went flying down. It went over this ridge over here, right over the ridge and over the top, and then down the Carbon River all the way into Ording and Umanclaw, and then all the way into Puyallup, Tacoma, and then to Commencement Bay. This is kind of what was left of the mountain. I mean, it was prior to, it lost about 1,600 foot of mountain during that event. So it was, and they know that because there's bedding in this little Tahoma mountain. So the bedding matches where the top of that mountain would have been. So that's kind of what the bedding looks like here. It's not a parasitic cone. That's an actual part of the original carapace that covered Mount Rainier. This is another rendition of what the top looked like at Rainier prior to 5,600 years ago. I mentioned all the snow that's up there. It's definitely a winter wonderland, and the snowfall that you have are just tremendous records in terms of how much that's how much they get every year. This year is no different. It was about 200 or 630 inches of snow. So that's roughly 50 feet of snow that fell up there by Paradise. And so the idea that you have this huge mountain that sticks up and then captures all the snow. You can see the crater up here on top here, and it grows all these glaciers. And again, continuing to hold their own in terms of the climate change because of the northern climes and just the amount of precipitation that falls on such a high mountain. There's definitely higher mountains up Mount Elias up in Alaska and Canada further north, but this one's near a population center, and you can see that there's glaciers pretty much everywhere. So you got a source of water, and then on top of that water, well, this is a crater, what it looks like on the top. And I'm not, Scott, do you know if there's a lake under there, or it's probably frozen, huh?
Sometimes there is.
Okay. So the trick is you can see these people walking up here in terms of scale. It's a huge mountain up there. Glaciers have receded some, but again, they're towards it above the 50 or the 7,500 foot mark. Those glaciers up above are again holding their own. These are off limits to go up there. I think you can go if you're brave enough, but I think the National Park Service discourages this. But all right, so these things are melting on the inside. So what the heck's melting them? And this is what the summit ice caps look like. Quite a network of them, and this is where the water flows when it melts in the spring. It tends to go north towards Commencement Bay. But what's heating them is these fumaroles, which are laden with sulfur dioxide, which, all right, so they're hot, so they melt the snow, and they create this basically sulfuric acid, which wreaks havoc on the rocks. And, that's kind of, that area up at the top of the mountain is basically, I mean, we looked at the pictures of Mount Rainier at the beginning, and then you have to kind of turn to yourself and say, well, the top is rotten. I mean, there's nothing up there. And you wonder what's holding it up is the other thing. And this is what Crandall went through. I mean, this is the incredible part of his study. He really got down on hands and knees and looked at all these, what he found in terms of the byproducts of the basalt and the andesite, when you mix it with sulfuric acid, what you end up with. So all these fairly specific types of clay, smectite and catelinite are all through is riddled, the mountains is just riddled with these things. And that's kind of what it looks like. I mean, if you're a climber, you're probably not going to hit your rocking or your rock assist to some of this stuff, because it's definitely I don't, does it look rotten to you? Yeah.
It looks rotten.
All right, and this is the smectite, and that's the stuff that when these mud flows get going, it's slippery mess. So these are some of they fly the mountain now with a lot of fairly sophisticated telemetry here, and you've got this red state. You'll notice it's over here on the west side of the mountain. You've got this is where the Osceola mud flow flowed through here. And this is the area of concern. That S stands for Sunset the arena, and that's the side of the mountain that USGS is really paying attention to, the Sunset Amphitheater. And you see the highly altered state of Mount Rainier. Again, another picture of, you have the conduit of the circulation of coming this meteoric water. You've got water melting from the heat from the volcano, soaking down into the crater at the top of the cone, and you get all these types of clay over here on the far right there. And that's really where this thing came from. This is looking up the mountain when the mud flow let loose. And again, it went up over this 600-700 foot mountain right over the top of that thing. And that was the mud flow that created all the way down into that area where Ording is. You see where Ording is actually gets into a couple of tributaries there. And that's all the way down to, again, we saw this slide earlier, but that's as far as the Osceola went, all the way up into Renton and into Duwamish waterway. Rainier is definitely watched, and the population centers are, because they're so close to Rainier, that's why there's so much concern. But Mount Adams has got the same issue. If you can see the rental, the altered area is actually more almost weighted on the west side. It's more of a potential, but the fact that nobody worries about it is because there's no people up there. So you know, there's definitely a greater concern up here at Rainier. So we're going to turn our attention over to the west side now. I mentioned that this side is highly altered. You've got the Sunset Amphitheater there, and then on the south side you got the Tahoma side, and this is kind of what it looks like. Again, this is the one that, talking to the USGS people, they said this is what we're worried about. So you've got the S and the T, the Sunset. That's the side that they're worried about breaking off, and then this is the Tahoma side. That's kind of the southwest corner, and that would flow towards the Nisqually River down towards Ashwood. Another picture of the sides that they're concerned about. And this side over here, that's the east side where the Osceola went down. And so they're less concerned about that side because all that material's since been released. All right, so these are the routes that it would go. These are definitely, this is the beginning of the Puyallup River here. And then the flow that came down through the year 500 years ago went down as far as Electron here. And then you see the ones coming down towards Tahoma Creek. This is kind of side view. Pay attention to this 13,000-foot elevation loss in 31 miles. These numbers will come back here in a minute, but that's kind of the side view of what we're looking at on a path through there. And then the idea that thing would, this is looking at the top, and they've since put all this instrumentation in. You can see that these big X's are instruments that they know they're going to lose, but they want to have the earliest warning they can get. And these are seismographs, these are tilt meters, these type of things. So they're instrumenting the heck out of that. Another picture of where the devices are that they are trying to pay attention. And you can see the time that it takes to get these different places. You saw that elevation profile. Once it flattens out, it slows down tremendously, but still just 45 minutes from Ording. Talking with the USGS, they figure the best they can get those instruments up there, they're live now, and it's going to take them at least 10 minutes to figure out they've got a mud flow headed towards Ording. And so that's the route they would take on the Puyallup side. And the purple line is the old Carbon River, which is where the Osceola mud flow came and filled up this whole area. So the USGS has done simulations of this, and they've figured this out in terms of what these things would look like. So you keep your eye on the time up there. It takes, less than a minute for that to happen. It's off to the races. Now, know that this is definitely a lot of material coming down, but you got to multiply that by 4 because it'll pick up stuff as it comes down. So you're looking at just a fourth of what's ultimately going to hit the town down in the plains down there. And so that's one look, and this is coming down into Ording. And you can see the time on that. right there. So 40 minutes and it hits the valley right at an hour. And that's kind of important. Keep that in the back of your mind. You folks at the PTA, this is you can see how it's, the previous mud flow has bound the whole flow into the town of Ording. And they are definitely aware of this. They see this stuff, and the USGS has been working right close with them. And you can see the times on this all the way down into Sumner and the Puyallup, and then if it goes towards Commencement Bay, it's going to take about 5 hours. But it's definitely this would be a major event, and it'd be the case one, the one that's full of clay, which there's plenty of clay up here. Then you've got the other way of going down through the Nisqually River Valley in this area, and you've got a catchment here at Alder Lake. We'll talk about it in a minute. But those are the two. These are the two routes that they're most worried about, the ones off the west side. And so, you can imagine that we're switching now from the USGS and we're switching to local governments as to what to do about this. Everybody knows about it. It happened, in 1985 with the Armero tragedy, which I'll discuss here in a minute. Everybody got pretty well shook up about the fact that they need to do something. Now, my concern is, what it is they've elected to do, and we'll discuss that in a minute. But let's talk about this. The obvious things: don't build in a mud flow zone. Okay, we can plan that. And what's that mean? Well, this is you're getting ahead of me. All right, so this is basically what they've passed, and this makes sense. I mean, this is good geology. These are I just threw in I don't expect you to read all that, but this is case 1, case 2, case 3 type of mud flow. I mean, if you just have a landslide that's local, that's a case 3, and the one at the top, the case 1 is mostly clay. The case 2 is not a lot of clay. It's mostly just rock and debris. So the ones that's considered the most severe is the case 1. And that's kind of what they talk about it here. So they've passed laws that tell you what the problem is, and then they tell you what we're going to do about it, okay? These are the facilities that they're worried about, and they're basically saying none of this type of usage is allowed in this area, okay? Well, okay, well, that makes sense. I mean, so it sounds like they've got good laws and good people thinking about how these laws ought to be interpreted based on the geology that they have. But, as I said a minute ago, this sits here. That was built 150 years ago, right after the Civil War. Actually, it was a little later than that. But anyway, I talked to them and they said, well, I said, what's your plan in case you get a mud flow? He says, well, we're going to go up the hill. And I says, okay, well, how many folks you got? He says, well, we got about 70. And I said, well, are they infirmed? I mean, are they able? And they said, well, not really. I mean, so, I'm trying to think, well, they're right next to the hill. So, maybe they can pull that off. I said, do you have any plans to evacuate, or relocate out of the valley? And he says, no, almost like, why should we, So, I mean, you get that kind of dealing. And I talked to these folks, and they only have about a dozen folks at these places. And possibly, they can handle that in an evacuation sense. But all right, so that's what you do. You pass laws, and then you hope people will do it. Pat Pringle says that the town continues to annex land that's down in the valley and build subdivisions. So he's not quite sure that they understand the tenets of this law where it says not allowed. So that's concern. You can also build devices that's going to manage the mud flow. In 48, they built a dam over on the Carbon River, and it was mostly for floods because Rocky Crandall hadn't discovered that there's mud flow potential yet. So they built this structure, and it's mostly dry, okay? But it would make a great retention structure for a Lahar. So that's on the Columbia or the Carbon River side. It was built in 48. It's been used maybe a dozen times to manage floodwaters coming off Rainier, but by and large, it would work fine for a retention structure. And this is one I showed what they do in Japan for that. They reroute a Lahar. A soupy one would get relocated pretty well. So that takes care of the, that's where this mount retention structure is over here. Again, that's where the Osceola flood or flow went. But let's look over here on this side where you've got this Alder Dam. It's 300 feet high. Now, would that serve as a retention structure? And the answer is, well, this is what it has to deal with. This is the Houma Glacier coming down the mountain, and it's gonna, go similar to what's happening just on the other side. This Sunset side is over here, and this is kind of more to the southwest. So the potential is there. It's definitely something that they want to pay attention to. But this is where it's going to flow. It's going to flow into this reservoir. Okay, you've got a dam there that was actually it was increased its height back in 45, and it's a pretty good sized reservoir. And then just downstream, this is the Alder Dam, the one upstream in the reservoir. And then downstream on a run of the river thing is another dam. So you've got two dams within a couple of miles there that are going to capture this mud flow. And so the concern I have is will it, or could it, or should it, and I've been assured by the USGS that that's not a problem. That the Alder Lake will they'll work with Tacoma Power, and they'll lower the water. And I said, well, that works fine if you have if you've been alerted to the risk. I can't imagine they can lower the water fast enough, especially in after a heavy spring or something like that. But their attitude is that that this lake would handle the flow, and they're not worried about it. The USGS is saying this. Just downstream from Alder Lake Dam is Native Americans. There's a few reservations just downstream from there. But you can see it after it fills up. Tom Sessions, I can't say his name, but he's the one who said that we think that the lake will handle the flow. So the USGS isn't worried on this particular side, but I kind of am. So I don't know if I have a worry or not here, but this seems to fill it up a lot quicker. And then the high idea that you'd have a reservoir that's going to capture this flow. The idea that that it says that the dam's capable of withstanding this. So that's their working position right now. I didn't talk to anybody at Tacoma Power, and I don't know that they have enough time to lower the reservoir if they hear that there's a Lahar coming.
How high would a tsunami generated by that overflow?
Well, yeah, they said that it would just absorb it all, and I'm not sure. I'm with you, Clay. I said, well, wait a second, you got a tsunami effect here. The other thing you do is you warn people as quick, and this is what Sheila and I put this whole package together earlier. All right, so what's key here, and the USGS is quite proud. They've got 92 instruments on Mount Rainier alone. I mean, that's amazing. In my book, I mean, certainly there's more on Mount St. Helens, but there's 92 on Rainier alone. And these are GPS locators, so they measure any deformation, and tilt meters do the same. Cameras, they can keep an eye on Bigfoot, and all this other stuff that they're using. And again, this is all these ones in black they're putting in this year. So they're definitely spending money up there. But then you do have the, the one that they have put in is what they call an acoustic one. And these are basically just listening devices that listen to rocks in the river roll. So it's probably good that this was automated, you know. I don't know if you'd want to do that job, Paul. No. Oh, okay. And this is what these things look like. They just go out there and then they listen to the rocks roll in the river, and then they send out a notice. But you know, the idea is you know, they at least plan on using sirens, which, you know, Maui didn't. And I think sirens are a good way of getting people alerted. I mean, it's an old fashioned way, but I think it works. So what you have to do is try to get people to evacuate and then afterwards rebuild your structure. So this is kind of what they are doing in terms of sirens in the Puyallup area. Of course, I didn't have any sound before. I'm not sure I'm gonna have sound now. So what this, you can go on YouTube and listen to this thing, but there's a fire signal that they test this out every Monday, once a month on a Monday, and then they've got it goes up and down is a siren, but the community can hear that. Yeah. Sorry. I don't know how to turn on the sound. Oh, okay. But yeah, these are all the sound sirens that they have. And they blink on for people that are deaf. So they, you know, so the idea that they're using sirens is to me, it's a good thing to do.
Got them all over the town.
Yeah. And you know, comes in different languages and that sort of thing. But you know, just keep on going. So this is basically they also test the evacuation acumen of all the schools, and this is the path, one of the roads going up the hill, and basically what they're talking is that, and they go from year to year trying to shave minutes off the record from a particular school to safety. So they're definitely working on getting these kids out of the harm's way. But you see, most of these routes are right into the direction of where the Lahar would come from. So to me, it was a little confusing about that. Anyway, so that's what the local government's doing. That's what you guys are doing. You're putting in these sirens, okay? And all these are all keyed into these tilt meters up on Rainier. So everything's tied together now, and they're working diligently on that. So kids get a walk and get up the mountain there.
How much time do they have?
Well, we'll get to that.
Okay.
Earlier, we showed somewhere about an hour is what it takes for, pardon me?
We know what their record time is?
Uh,
For getting everybody up.
I didn't ask them that. I've talked to several folks there, but they're quite proud of the fact that they do this, so. And, you know, I think, you know, there's a lot of triggers, as we said a minute ago, on these Lahars. The worst case scenario is there's no warning. And that's the one I'm worried about. Now, if you have an eruption, or if you had a rain on snow event, or if you had, there's a lot of other producers of Lahars that you're going to have plenty of warning. So this will work for 5 out of 6 potential mechanisms for creating a Lahar. But you know, this is kind of why I threw this scenario in here. This happened in November 13th, 1985. And this was something they knew about. Okay, so basically you had some mountain climbers that noticed there was an increased output of gas from the top of Nevada Del Ruiz in November of 84. And so every geologist that made 25 cents descended upon Columbia. There were a lot of people who went down there to see if they could give a hand to it. The town of Morrow, you can't see it, but it's over this hill. This is from Bogota. You can see the mountain. It's huge. It's got a small snowfield. That's about a tenth of Rainier's. But you know, this is kind of where the mountain was, and these brown paths are the routes of these Lahars. All right, so you know, this was Spanish. The Spanish came into this country back in the 1500s, and you see they experienced a huge Lahar back there in 1595, and then again in 1845. And so, I mean, it was like, as with Rainier, we've known that this community is at risk for Lahars. Okay, there wasn't any doubt, and a lot of the literature talks about it. And you could see what happened ultimately, and this is after the 85 event. So, I mean, given what we know about Rainier and given these evacuation drills that we're doing, I think that's all laudable. But kind of what happened with Morrow is this is the full path for decision making in Colombia at that time, and this is kind of part of what happened. If you read the account, somebody would get a piece of information, and they would have to call to finally get confirmation of that, and so they couldn't act. And this happens in Guatemala quite a bit too. You know, a person's not going to want to take full responsibility unless it's blessed by somebody up high. So this is kind of a flow chart of how you make a decision. This is prior to the tragedy. Okay. But here I'm trying to say is these people they felt like they were on top of this is the lesson here. This is the route is in the blue. It takes basically it takes quite a bit to it's 90 kilometers to drive it up to here. But this brown line is the route of the Lahar, and you'll see this 13,000 foot of elevation loss over 32 miles is what that blue line is, or excuse me, the tan line is. That's exactly what Ording's looking at, almost to the foot. 13,000 foot of loss in about over 30 miles. So that potential in this particular case, it took about 2 hours for the Lahar to get to Armero. And you know, what happened here was they had the initial alert in November of 84, and all through the year of 85, really nothing happened. Okay, and everybody fell into a lull. And I bring up Mount St. Helens because that's exactly what happened here. You know, and I talked to Pat about that. He says, you know, we really didn't know what and how this volcano was going to react. And you get some of this hubris by the state officials saying, you know, we can't figure out, you know, anything about this. I mean, we knew this thing was going to happen, and this was in late April is when he made this quote. So Dixie Lee Ray, she basically, right when the eruption started in March 27th, she declared this red zone. But if you look at the red zone, this is basically just 3 miles from the crater. And so I'm gonna, for my next talk, I'll try to figure out who designated this red zone. But the red zone was way too small, I guess, is the question. And then, as you know, you guys that all live here, just before the the day before, the governor did allow people to come in all the way up to this red line. Now you see this Coldwater Ridge right here, the red line went just below it. So that's where Davy Johnson was sitting, right on Coldwater. All right, so again, we have good science. The science isn't perfect because, they're scientists. They say, well, this is our opinion, this is a hypothesis. And I think that public officials take that and kind of that uncertainty and they run with it. And they say, well, we're going to just make this puny little red zone and call it good. Well, this is kind of what happened. And the red zone you see is on there. And these little dots are where all the people the 57 people that died were located. And, this was kind of a complacent thing where we had the knowledge that we had this eruption. We didn't know when it was going to erupt. When it actually did erupt, it was a surprise. But Davy Johnson was right here, the geologist that died. And then you had Harry Truman that was down here. And I don't know who that number 2 is. But there was only 2 people that were in the red zone, and everybody else, Dixie Lee Ray said that these people were all illegal. That was not true. These people were all in there because they could be in there. The government just said that was fine. And so all these folks that did get killed didn't have to be. And that said, again, the numbers weren't great, but all I'm saying is we had the knowledge, and the way scientists work, you actually qualify what you're saying, and then a politician's going to leap on that and take it and run with it and say, well, you really don't know what's going on. As you know, this is the end of the blast zone, which basically killed all those folks. But let's go back to Ruiz, and this is kind of the timeline. Again, you had it started to erupt. Thousands of scientists went to Colombia to see if they could help. 2 months before it actually erupted, it started to renew activity. And they started to distribute maps, and they felt this was getting serious about it. And then just 2 weeks prior to the eruption, a geologist issued a report saying the eruption was imminent. But they didn't evacuate. This is the map they passed out. Now I'll let you guys look at it for a second and see if you see anything glaring with this. If you were to look at that map, would you evacuate if you were in Armero? Huh? Yeah. So this is the map that that they published. And so you look at that map and you say, well, all right, I'm in the green zone, I'm fine. So a lot of people took that to mean exactly that. They said, well, we're okay, and we don't have to evacuate. The other thing that really complicated thing is the government was really distracted. They had a group of rebels take over captured all the chief justices. They had 25 chief justices, and they actually ended up killing 11 of them. So the government was clearly distracted. They were not paying attention to Armero whatsoever. And, they basically had these long period earthquakes, and I think the geologists told them that this thing is starting. It's going to erupt, and so they basically tried to get word to Armero, but there was ash flow that was falling on them, and the local people told them just to stay inside because they'd stay out of the ash. And then they tried to get a hold of them. They finally made a decision. You saw that chain of command that was up there. All the local people knew they wanted to evacuate, but they had to get permission from Colombia, from Bogota before they issued it. Again, they didn't want to get in trouble, so they went and they never got word back. And then finally the word was to evacuate it at 7 p.m. And then a thunderstorm came through there, probably generated by the volcano and the vigorous action that was going on, and then basically they couldn't get the word to them. So nobody at Armero knew what was going on. Then what happened was at 9 p.m. they actually did have I guess a moderate eruption is by all case. It certainly wasn't a major one, but the ash cloud went up, and as the pyroclastic flow descended on that snowpack, it melted it in very quickly. And then the first of 2 hours later, the first of four Lahars, major Lahars, hit our marrow, and the people didn't have a chance. They basically nobody came to help them. When they because everybody was hunkered down, and so nobody came, and so there was no communication whatsoever. They finally realized nobody was answering at our marrow. They basically said they tried to get there and they couldn't get there. Once they got there, they couldn't do anything. The mud was everywhere. And these kind of situations, we're going to have an ording. Basically, you got to have that, that sticky mud, and then the water. You're not going to be able to get in there. And then just prior to there in September, they had a big earthquake in Mexico City. So all the big medical, staffs around the world were up there in Mexico City. They didn't have people to send down here. So nobody really came to help these folks. And, this is kind of the mountain with the ash on it. And then you can see how it scours the hillsides and adds 4 times the volume to the volume of the Lahar going down. And it went down there at 40 miles an hour. It basically started at roughly about 9:30 is where the pyroclastic flow occurred, and it hit at 11 p.m. And it leveled the town with all this mud, and this is there's no equipment. The government sent no equipment, and you had this is actually the same picture of folks trying to rescue people out of the mud. And this is again identical to what we're going to deal with in Ording. Again, another shot of that of the flow down there. Again, we had one in 1595 and again in 1845. So it's not like we didn't know. This particular heart-wrenching photo was taken by Frank Rainier. This girl, 13 years old, was trapped with a big concrete beam across the back of her legs, so she couldn't move, and the water kept going up and up. They tried to get a pump to her, and she couldn't. The pump. They finally just started bailing the water out with buckets, and then she passed away right there. Nobody could help her after 60 hours in these conditions. So, and they basically used her to symbolize all that was wrong with the Colombian government at the time, because again, nobody came to help this town. It's a sobering story, but it's this is one where I would say they were fairly sophisticated in their approach to the mountain as we are, and yet I'm not sure that all the right decisions were made at that time. These are the evacuation routes in Ording. I'll blow that up here. But this is in Ording, where you see where the Ptarmigan Ridge School is located, and then you have these evacuation routes that are going to the south here. I'll make them a little bolder, and this is where the flows could be coming from. So they're coming at you as you walk towards them. And I kind of questioned them about that, and they said, "Well, we'll have time." And I just don't quite get it, because again, I did this little Google map thing trying to figure out how it's 3 miles for these little, second graders to walk. They probably can do it in an hour, but man, I tell you, they're going to have to. Here's the issue. The issue is you don't have any time. I mean, you're not going to realize that you've had a Lahar. Say it hits right at 9 a.m. You're not going to know until 9:10. So you've only got 50 minutes and to get to the top, and this thing takes an hour to walk. So I just questioned their math. I said to a couple of folks, I said, "Well, how do you do that?" I mean, I don't know what they're thinking. They're thinking evacuation by walking is the remedy. So that's the local government's decision. So you guys on the Zoom call, I need the PTA to respond to this. Again, this is where the school is over here. You can see it's right in the middle there. This is the depth of it. It's going to be right at 2 to 3 meters. So, 9 feet of mud. I mean, that's kind of what happened in Armero. There was 9 to 15 foot of mud pretty much everywhere. So your ability to reach kids that are in here is nil. I mean, you're not going to be able to get there. Again, this is the walk time. You can see that school is right where it's over 60 minutes to get to safety. And if I were a PTA person, I would be livid with the school, but or I'd move or something. Again, that's where the school is, and yeah, and the orange line. I calculated a route. If you build a bridge over the Puyallup River, you could get up and out of harm's way in 30 minutes. That's one idea. Another idea is this Blue Star, which they call the emergency evacuation bridge, which in itself, it doesn't really do anything other than it's high. And if it's high, you're going to be above the flow. So, I mean, if they're building it hell for stout that it will stand a Lahar, then I think it's an okay idea. All right, so, but that's right near Ptarmigan Ridge, but I would make it, big enough so to where it could be something like one of these things, which is the state of Washington's building these vertical evacuation devices that you can, like out on Long Beach and on the Long Beach Peninsula there by Ilwaco. I mean, if you're out there when the tsunami hits, you're going to have to. There's no place to go. I mean, you're not going to, unless you have a boat or something, I guess. Anyway, so they're doing these things all up and down the Washington coast. So I suggested to them they do something like this. It doesn't have to be so high. It's got to be at least 20, 25 feet high, but it's got to withstand all those big boulders that you saw coming down there. So with that, I'm going to turn it back to you guys in terms of the USGS. I think I don't want to put words in your mouth. If you guys got a spokesperson over there, what would you do? I've already asked John Major this, so I know the answer. Do you have another recommendation you could do for the city of Oregon? That's your question. Question for the local governments here is, are you guys satisfied with your basically your philosophy to let these kids walk to safety and the folks in the assisted living place? I mean, but again, you guys are shaking your head, but you're part of the local government. And then you folks on Zoom, I got to hear from the PTA. What would you do? I guess is the question. And so this is kind of it's a real problem right now. And if you put yourself in the shoes of the folks in Armero, they felt that the government forgot them. And I don't necessarily disagree. I mean, they've one little anecdote since May until August, Nevada Delta Ruiz did start acting up again, and this time they did practice a lot of evacuation. So they've kind of learned their lesson down there, and the idea, I didn't show it there at Armero, but there was a lot of high ground right next to the city that they could have easily walked to in 15 minutes. So Salvation was real close to them there. I don't see that the case in Oregon. So with that, any discussion? Anybody want to venture out what you would do if you were the US?
I'll let you know. So Wes on the Zoom call early on at 7:42, said as a member of the PTA, I've pretty much already decided to move to an area either a few hundred feet higher in elevation or across on the other side of a very high ridge, or even to Portland.
Okay, that's what's man.
People were agreeing with him here, so.
Oh, okay. All right, go ahead, Denny.
Kind of wondering where the school buses are parked and if there's. If you've done to keep them close at hand and how long would it take to load up a bunch of school buses? Maybe even construct an emergency evacuation to have that.
Yeah, the answer I got from them is that's why they're putting this bridge over this highway, because the highway is gonna be chock full of cars trying to get the hell out of there. I don't know how a bus system would fit into that,
Oh, yeah.
but I'm not, other than the fact that this is an elevated structure, I'm not sure what this overpass would do.
I think the bridge structure should be carried over to the high ground there. It should, at least give them not have people piling on top of that bridge, hoping that's gonna withstand it.
Yeah, the bridge is right there. Yeah, you can get to 200 feet above over here. It's a little bit of distance. It's probably a half a mile mark, but you could definitely do that.
Well, do you have to cross a river?
Yeah.
You'd have to build a bridge, yeah, another bridge.
Yeah.
And pedestrian bridge shouldn't cost that much, especially if you decide it's only for pedestrians and it'll get destroyed by the thing eventually anyway, but at least it's there for the time we need to get across.
Yeah, you'd have to put a bridge here, or you could put a bridge here.
Yeah, OHS use like stairwell thing comes to mind.
Yeah. Yeah, I mean, you could do something. Again, the question, the pushback I got was, well, we wouldn't want to do that because these canyon walls are friable. They're falling down. But I would just use it as a way of getting people up. I mean, you could build a staircase that's, it's not gonna go anywhere. I mean, you can engineer that to get it up at least, you're get at least 30 feet high is all we're looking at.
There doesn't seem to be that many people in this town. I don't know what the population is, but like, I've driven through Yala and there's a lot of people there.
Yeah. They have time on there.
They're gonna get out of there.
Yeah, well, it widens out. Let me go to that next page. Yeah, so it turns the corner here and then goes out through Piala. Yeah, that's all heavily populated through here.
No.
It does widen out, number one. And number two, you're gonna get, the whole thing's starting to slow down. I think between Ording and Sumner, you got 2 hours. So,
Well, still. there's
Yeah.
a lot of people.
yeah, go ahead,
Do
Sheila.
they deal with just normal flooding during the winter? Because it looks like it's all within a floodplain there, or a lot of the houses. Do they deal on a seasonal basis with the?
Yeah, that's a great question. The question was, what about flooding, from a annual, runoff type event? The whole idea of, yeah, I don't know. I'll dig into that.
Nothing like being in a floodplain area.
Yeah. Any thoughts, Scott? I'm gonna call on you to wrap it up for the USGS.
They have a problem there, and I've been in this area at 5 o'clock. Oh, and it's just bumper to bumper.
Yeah.
It's a major problem.
So John Major, who runs the CBO, his attitude is, yeah, we would love to issue evacuation now and start the process. I mean, we do it along the Mississippi River, if houses get flooded year after year, then there's a relocation project. He says, Bill, we've recommended that they do just that. And that's as much as we can do as a government agency.
What is to get them all to move out? You said back.
Yeah. Well, if you go back to that law, Mark, that law says, none of this building down here is allowable. So I'm not sure, I think it's, you know, I don't, maybe it is just window dressing, but you know, there's certainly not. This is easy to build, but it's, you know, it's at, you know, extremely high risk. And I guess the essence of having you all here and talking about this is, you know, geoscientists are caught sometimes in some of these discussions about, you know, what you could and should do. And you know, you'd like, you know, Dixie Lee Ray, she was really on top of that. She made an emergency order just 4 days after the Mount St. Helens started acting up. The problem is she started listening to lumber folks, Weyerhaeuser down there and all that, and she really limited to that red zone. The red zone should have been out 15 miles in every direction. And she didn't do that. And she tried to cover her bases and she didn't get reelected because of this. It's my opinion that she didn't get reelected because of what had happened in Mount St. Helens.
I
But
think one problem isn't the soil that is, the Lahar deposit itself is a pretty rich soil, isn't it? Because there's all kinds of agriculture in those areas.
yeah, well, upstream from here, no, there's no, well, this whole area, Scott, you know this area better than I do. It's a high clay content. You know, let me go back to the catchment of where this thing's at.
It's like the plain that Enterprise one, it's all farms in there.
Yeah, oh, down, on top of it, yeah, on top.
Yeah, you know, the suspiciously flat area.
Right. Yeah, all that, yeah, it's all very flat, right? Except where the canyons are. And the canyons are, you know, a subsequent erosion. See, where was that? Oh, yeah, maybe there. Yeah, this is time, yeah, you get 2 hours when you get to Sumner. Yeah, all this stuff on top, you're fine. Just don't live in the river valley. Yeah, Clay.
Yeah, I'm also wondering about the instrumentation on Mount Rainier itself, where those two dangerous points are, you pointed out. Are they just going to rely upon one of those instruments failing, say, aha, it's collapsed, let's evacuate, or you have other types of instruments that are confirming, yes, this is really a collapse, it's not just a matter of the blew a fuse.
Yeah, well, I don't know if anybody's been up to Rainier, but these places are incredibly hard to get to, and they're really in harm's way, even putting the instrumentation in there, because you have rocks and all this crap coming right down. We're at the top looking straight down that mountain. This is the crater up here. So, you know, that's 1,000 foot down. I mean, I think the idea of putting instrumentation up there was pretty risky, actually. But, you know, they're putting them in there, and then they have to put instrumentation in such a manner that it's going to withstand, you know, 20 feet of snow and you know, all kinds of rock fall and all that crap. That's I mean, and these are the best sites that they could find, you know, in terms of stability as well as, I don't know, I'm answering your question.
Well, my concern is the fact, will the public believe it? If somebody says this instrument failed, we're pretty certain
Yeah,
landslide has started, let's issue it on. Or I think they need some way of confirming that it's really, you know, some other way of finding it out. If not, it's a seismometer nearby. Yeah, this instrument failed, the seismometers are jiggling, and we have this visual
right.
confirmation to a camera's mount here and there.
Well, they do correlate with all the other instruments that are there. I mean, they have cameras, they have tilt meters, they have seismographs.
And the public might not believe that.
Oh,
That we want to see a picture, show us the gamma.
oh, well, we won't have time for that. Any other questions? I would wrap this up. Anything on Zoom?
Gotta wrap it up pretty quick. Yeah, we
Yeah,
got.
Danny.
If anybody has ever guessed effective solution to evacuating a densely populated area on short notice.
Yeah,
Because the roads are just gonna saturate.
yeah, yeah. So that leads me to my last slide here. If I get there. I don't want to do that. How do I say, okay? Oh, well. Anyway, my last slide was, just to say, my next, talk is gonna be on the human condition, how to handle a low probability, high consequent event. So that's,
Hey, that's great.
all right.
Hey, that was a wonderful. That was really good.